In the last session, we have learned what is binomial distribution and its features. In this session, we shall start with the problems on binomial distribution. That is problem 8, which is continued from Bernoulli distribution. Before we start solving, remember that to solve this binomial Poisson, we require the statistical tables. At the end of the textbook, we have the tables. Just on the page, see the tables, how they appear. When you check out binomial, this is how it appears. N value. We need to use the combinations. N value. This is NC0, NC1, NC2, whatever. Suppose if we want the answer of 4C2. I repeat, if you want the answer of N as 4, R as 2, here N 4, 4. C2, NC2. What is the answer? 6. This is how we get it. Suppose if you want the answer of 6C3. 6. C3 we want. C3. What we get is 20. This is how the values are to be taken. We'll see that again in the very first problem. But see that you have your binomial distribution table with you, ready with you. Fine. The problem says an unbiased coin. Unbiased means which is not a biased coin. Because when you toss a coin, it has to be a fair coin. There shouldn't be any bias in that. Is tossed for 5 times, find probability that the tosses result in number 1 heads only and number 2 3 heads and 2 tails. Very first, denote x. See the steps. Denote x, write the parameters, find q, write the PMF and then start solving. Let's say, let x denote, how to denote x here? Let x denote the number of heads obtained in the toss of 5 coins. What is asked in the problem, based on which the question is asked to you, that itself will be your x. Now here we cannot take let x denote the number of male children born. Problem is based on a tossing of coin and resulting into head. So the x value has to be same. Let x denote the number of heads obtained in toss of 5 coins. If the problem is regarding the number, find the male children born. Let x denote the number of male children born. Find the probability that how many bombs hit the bridge. Let x denote the number of bombs hitting the bridge. What question is asked, that itself will be your x. Don't go wrong with that x value. Here they asked 3 heads and 2 tails. Now the question is, sir, why we have not taken here tails? Why heads? See here, in the first case heads, in the second case also heads. So 2 times heads are asked. So we go with heads. Then x is the binomial variate with parameters n. How many times the coin is tossed? 5 times. So n is going to be 5. Probability, p value we want. P means what? Probability of getting the head. Recall PUC1 probability. How we find out? Favorable outcomes divided by possible outcomes. What we take as m upon n. That is what we have done here. Probability of head m upon n. Total possible outcomes when a coin is tossed to either head or a tail. Favorable 1, we want head. So 1 by 2 is the answer. Once you get P, we get Q. 1 minus P, that is 1 by 2. Then write the PMF. See the steps. Number 1, denote x. Number 2, show the parameters. Number 3, show Q. Then PMF. Now we'll substitute the values in the PMF and then see how to solve what they have asked. So here probability of x is equal to n 5 combination of x. P is 1 by 2 raised to x. Q 1 by 2 raised to 5 minus x. And the range has to be shown every time. If you don't show the range in the exam, we lose marks for that. X 0, 1, so on n. Here n is 5. Range means here x won't take values more than 5. Because when a coin is tossed for 5 times, can we get 6 heads? We may get maximum 5 heads, not more than that. That is why in binomial the range is limited to n. Let's see. Number 1, what is asked? What is asked number 1? Heads only. Heads only means what? When the coin is tossed for 5 times, all are heads. All the times we get head. Let's see. Number 1. Probability, all heads, or we can say as heads only. So all heads, probability x is equal to 5. because the coin is tossed for 5 times. If they are mentioned 2 heads, x will be 2. If they are mentioned 3 heads, x will be 3. All heads means x is going to be 5. In this PMF, we'll put the value of x as 5 and solve it. That is equal to 5 combination of 5 into 1 by 2 raised to x is 5 into 1 by 2 raised to 5 minus x, that is 5 minus 5. Now 1 by 2 is 0.5. 0.5 will multiply for 5 times. Here, first we want 5c5. Check out. 5 c 5 is 1. Is 1. So 1 by 2 is 0.5. 0.5 raised to 5. What you get is 0.03125. Again 1 by 2 is 0.5. 5 minus 5 0. Any number raised to 0 is always 1, not 0. Any number raised to 0 as per the laws of indices is always 1. So when you multiply this, the answer what we get is 03125. That means the probability of getting all heads is very low, 0.3125. That's all. Let's see number 2. What is asked number 2? Probability of getting out of that 5 tosses 3 times heads and 2 times tails. Now the question is, what should be the x value? Should it be 3, should it be 2, or first we'll take it as 3 and then we'll take as 2? Very simple. What is x? What we denoted? Number of tails or number of heads? Number of heads. So in this outcome, check out how many heads are asked. 3. X is 3. Naturally, remaining 2 tails will be excluded. We are concerned with what x we have denoted. Let x denote the number of heads obtained. Check out in this outcome, how many heads obtained? 3. So x is going to be 3. In this PMF, we'll put up the value of x as 3 now. 5 combination of 3, 1 by 2 raised to 3 into 1 by 2 raised to 5 minus x, that is 3. 5c3 we want. See here, as per your table, 5c3. 5c3 is 10. 1 by 2 is 0.5. Multiply for 3 times. What we get is 0.125. Half. 5 minus 3 is 2. Half means 0.5 raised to 2. 0.25. What you get is 0.25. 10 into 1.25 into 0.25. The final answer is 3125. Is your final answer. That's all. This is how the problems on binomial are to be done. But see that whenever we do the binomial problems, you should have this table with you. Every time the table must be with you. Fine. So in this session, we have completed problem number 8 on binomial. In the next session, we shall take a problem number 9 on the same. Thank you.